name is Hannah. I'm the one who take you to the journey of microorganism and oxygen. As you know, oxygen is really necessary not for only human but also the animal, from the big one like an elephant or the small one like a crocodile. As we know, not the smallest is not crocodile, but the smallest is those bacteria, virus, who only can see through a microscope. And the question is it oxygen is necessary for them? Now we're gonna meeting Dr. Nielsen, who's gonna explain for you everything about microorganism life and has changed through along with the earth. Our audience have a small question to know: is it oxygen is real life, or is there anything can live without oxygen?
Okay, well, humans need oxygen, and basically all organisms need oxygen for their respiration. So then, if the world was without oxygen, then it would be pretty much barren, right? Well, no, wrong. Firstly, look around you, and you see grass, dirt, a stick, leaf. Like, if you look really closely, yeah, no, you still can't see it. No. Anyway, surprisingly, they're actually teeming with life, and we can't see them because they're so teeny tiny. Hence the name microorganism. They basically have been around since before oxygen even existed. They actually started off anaerobically and eventually adapted to become aerobic.
Yep. So the second question we want to ask, you have mentioned a lot about microorganisms. So what exactly is it, and how tiny that I can't even see it on the leaf?
Okay, so these microorganisms are made up of bacteria, fungi, yeast, viruses, and protozoa. So these can't actually be seen by the naked eye. Most of them need a very high magnitude or magnification. And the smallest is actually a couple nanometers, which is the virus. And the biggest is actually a bacteria, which is about 0.1 to 0.3 millimeters wide. So you can actually see the biggest one, except the only thing is that it's in the coast of Namibia, so don't hold your breath.
Okay. Professor Harrison, who is specialist about microorganism history. He's still busy. Hello, Professor.
Hello, how are you?
I'm still good.
Great.
Okay, so today I'm here to ask you some questions. We have no microorganism is like bacteria, fungi, or yeast, but we didn't know how have they changed throughout the history.
Well, some microbes have changed throughout history, and some actually haven't. Some microbes have been using the same biological systems for years and years and years, like millions of years. But the ones that have changed through this process of evolution. And evolution is basically just an organism changing throughout generations in response to the environment that it's in. And evolution is also determined by a thing called fitness, which isn't actually how strong or how fit an organism is, but more to do with how well an organism can actually reproduce and pass on its genes to the next generation. And that's how evolution comes about, and that's how some microbes have changed.
So far, what did you observe through those microorganisms about the change of it?
Well, believe it or not, but about 3 million years ago, oxygen didn't exist. Well, not in the large concentration where it exists in our atmosphere today. So before mammals and other animals roamed the earth, it was ruled by microorganisms and tiny little organisms that we can't even see. So they weren't using oxygen, they were using sulfur as their energy source. And that's pretty much how they lived. It's how they adapted to be anaerobic, so living in an environment that doesn't have oxygen.
Oh, it's quite impressive.
Yeah.
So as you say, in the past history, at the beginning of the Earth, the oxygen, so is this a really small concentration? So is it okay that the microorganism can live with that tiny oxygen, or like no oxygen mean no life?
Well, back then, no. If there was no oxygen today, we'd have a pretty hard time with pretty much everything living. We'd stop living because oxygen is so essential. But back then, they developed a way to live without oxygen, and that was called an aerobic metabolic pathway. And pretty much what this means is instead of using oxygen to breathe in and transfer energy around their body, they use other substances that they could find in their environment, such as sulfur. So instead of using oxygen to move electrons around and get energy to the parts in their body where they needed it, they used other substances to make that pathway happen.
Okay. So as you say that microorganisms have changed through history a little bit.
Yeah.
So if those ones not changing, still they can live in this environment?
Yeah, so some microorganisms are still anaerobic, meaning they don't need oxygen to breathe. And some of those organisms are still present in the world today. And they're direct descendants of the organisms that were around on Earth millions and millions of years ago. However, anaerobic microbes in the world today are what's called extremophiles, and they're found in really harsh environments, like in volcanoes or like deep sea, like lava vents underground. Really, really extreme environments where oxygen isn't very readily available, and they need to be able to live without the presence of oxygen. So they do still exist in some places, but they're pretty hard to find, pretty hard to come by.
Today we're gonna meet Dr. Snoot to tell us about the adaptation of micro to the life. So just want to ask you, when did the adaptation really occur?
So the adaptation of microbes, like anaerobic microbes, occurred 2.5 billion years ago. So at that time, there was only anaerobic bacteria living, and most of these all lived in the ocean. There were some aerobic bacteria known as cyanobacteria, and this is where it all changed when this started to produce oxygen.
Oh. So you have mentioned about cyanobacteria. So what exactly the effect of that kind of bacteria in the adaptation?
So cyanobacteria is in the ocean, and it was one of the first things to start using photosynthesis and producing oxygen. And at this time, anaerobic microbes, oxygen is very bad for them, and this oxygen would bind with iron in the ocean. As soon as those reserves were full, oxygen began to become free in the environment. So over billions of years, oxygen built up, and that's when aerobic microbes first came about.
The last question I want to ask you is what the origin modern of the aerobic organism? Yeah.
Yeah, so with oxygen now being more available in the atmosphere, anaerobic microbes can only cling on to what environments had no oxygen, and this allowed for the aerobic microbes to grow, expand, and become more available on a larger scale. But the theory about the modern aerobic bacteria, how it evolved, is the fact that it's known as the endosymbiosis theory, in which an anaerobic bacteria engulfed aerobic bacteria and failed to digest it. And this aerobic bacteria living inside the anaerobic bacteria, since there's such high availability of oxygen, began to produce more energy than what the anaerobic bacteria did without oxygen. So over time, it now became known as what is mitochondria, and that's what all living cells that make up you and me